Hi, I am Revathi, Assistant Professor, Department of EEE, SNS College of Engineering, Measurement and Instrumentation Lecture Series video. Today's topic is about resistive transducers. A review of a previous slide is transducer definition, advantages, requirement, classification, and selections. So, a definition of a resistive transducers. The transducers whose resistance varies because of the environmental effect. Such type of transducer is known as the resistive transducer. The change in resistance is measured by the AC or DC measuring devices. Some of the example of resistive transducers are the application of resistive transducers include potentiometer, resistive thermometer, strain gauge, thermistor, etc. These transducers are used to measure displacement. The best example of these transducers are potentiometers like rotator and translator. Working principle of a resistive transducer. Working principle of resistive sensor. A resistive sensor works on the principle that the conductor length is directly proportional to resistance of the conductor, and it is inversely related with area of the conductor. Therefore, L is denominated for conductor length, A for area of the conductor, and R for resistance of conductor. Resistive transducer working principles. On the other hand, this length is inversely proportional to the cross-sectional area of the conductor. The formula to calculate the resistance here is R that's equal to rho L by A, where the R is the resistance, L is the length, and A is the area, and the other parameter is the resistivity. Some of the application of a resistive transducers are the application of resistive transducer include potentiometer, resistance thermometer, strain gauges, thermistor, etc. These transducers are mainly used to calculate the temperature in several applications. The application of resistive transducer include potentiometer, resistance thermometer, strain gauges, thermistor, etc. These transducers are used to measure displacement. The best example of these transducers are potentiometers like rotator and translations. The resistance of these can be changed with the deviation within their length to measure the displacement. The semiconductor materials resistance can be changed when the strain happens on it. This property can be used to measure force, displacement, and pressure, etc. Some of the disadvantages of resistive transducers are when using these transducers, huge power is necessary to move the sliding contacts. The sliding contacts can exhaust, become uneven, and produce noise. Thus, this is all about the resistive transducer, which is used in different application within the measure and transaction like pressure. Mechanical strain, displacements, load, force, temperature, as well as the velocity of fluid velocity into electrical outputs. These apparatus are based on the change within resistance brought about through the measurement. Here is the question for you. What are the example of resistive transducers? Comment in the comment section. Some of the advantages of resistive transducers are the advantages of the resistive transducer including the following. This transducers give quick response. These are available in different sizes and they have high resistance. The voltage otherwise current for both the AC and DC is suitable for calculating variable resistance. They are low cost. The operation of this transducer is very easy and used in various applications whenever the necessity or not mostly serves. These are used to measure the huge amplitudes of displacement. Its electrical efficiency is extremely high and gives adequate output to let control operation. Strain gauges. Strain gauge, a resistive transducer. A strain gauge, resistance strain gauge, is an important type of resistance transducer whose resistance varies with applied force. It can be used to convert force, pressure, tension into change in electrical resistance. The applied strain can be measured by this change in resistance. Assessment. What will happen to resistance if the length of the conductor is increased? What will happen for resistivity metal and semiconductor if the temperature is increased? What is the relation of temperature coefficient of resistivity on the coefficient of thermal expansion in RDT? A metal with temperature coefficient of resistance has a value 200. Its initial resistance is given by 40 ohms for an increase in 30 degrees Celsius to 35 degrees Celsius. What will be the final resistance value? Thermistors may be in wire form. Comment the answer in the comment section. Strain gauges. A basic types is or a passive transducer. Uses the variation in electrical resistance in wires to sense the strain produced by the force on the wires. Used for measurement of strain and stress. Load cell, torque meters, pressure gauges, temperature sensors employ strain gauges as secondary transducers. What is piezo resistive effects? Change in the value of resistivity when the conductor is under stress. Types of strain gauges: wire strain gauges, unbounded wire strain gauges, foil strain gauges, thin film strain gauges, semiconductor strain gauges. Resistance thermometer. Resistance thermometer of RDT requirements: does not generate own voltage, requires separate voltage sources, used with Wheatstone bridges. Thermistors, thermally sensitive resistor, negative temperature coefficient.